Assalamualaikum and good day everyone. My name is Nur Anisa Katika binti Abdul Rahman and I will be the first presenter for this group presentation. Today, we will like to present our research title, The Relationship Between Sport Motivation and Academic Performance CGPA among students who are active in sports. Before I proceed, I would like to introduce my group members. The first one is Rafshan Hazim, Ashraf Imran, Atila Alia and Siti Nobalkish. Okay, next we go through to research objective. Research objective 1, to measure the total score of sport motivation among students who are active in sports. Next, research objective 2, to measure academic performance measured by CGPA among students who are active in sports. Research objective 3, what is the relationship between the total score of sport motivation and academic performance CGPA among students who are active in sports? Okay, next we move to hypothesis. For this study, we formulated two hypotheses. The null hypothesis states that there is no significant relationship between sport motivation and academic performance CGPA among students who are active in sports. Meanwhile, the alternative hypothesis states that there is a significant relationship between sport motivation and academic performance among students who are active in sports. With that, I will now hand over the presentation to the next presenter. Thank you.
Transfer data from Excel to SPSS software. Firstly, transfer data that has been collected from Excel to SPSS. So we need to open the SPSS. Click File, then Import Data. Click Excel, and click Excel file that has been filled with the data collection. Then click OK. The data will appear under the software. Then make sure there are no missing data from the Excel. We check first the data to make sure that there are no missing data. Next, we go to the variable view. In the section, put the value 1 for male and value 2 for female. Then click OK. Add type of sport. Put the value 1 for individual and value 2 for team. Then click OK. Add question 1. Put the value 1 for does not correspond at all. Value 2 for correspond very little. Value 3 for correspond little. Value 4 for correspond moderately. Value 5 for correspond quiet a bit. Value 6 for correspond a quiet lot. And thus value 7 for correspond completely. Then click OK. Next, we copy the value that have added at question 1 section. Select and that from question 2 to question 18, but then paste. Next, we go to the measure section. We copy scale from CGPA section, select and that from question 1 to question 18. Then paste.
Now, we move on to compute variables to calculate the scores for 6 different subscales and total score of sport motivation. First, click transform and click at the compute variable, then add the target variable, name it to intrinsic regulation. In the numeric expression, construct an equation of Q3 plus Q9 plus Q17. Click OK, the new data of intrinsic regulation will be generated. Now for the other subscale, click transform and then click the variable, compute the variable. At the target variable, name it integrated regulation. Construct an equation of Q4 plus Q11 plus Q14. Follow the same step until 6 subscale. Click transform and click at the compute variable and at the target variable, name it to identified regulation. In the numeric expression, construct an equation of Q6 plus Q12 plus Q18. Click OK. For the fourth subscale, click transform and click at the compute variable and add the target variable, name it to introjected regulation. In the numeric expression, construct an equation of Q1 plus Q7 plus Q16. Click OK, the new data of introjected regulation will be generated. The fifth subscale, name it to external regulation. In the numeric expression, construct an equation of Q5 plus Q8 plus Q15. Click OK, the new data of external regulation will be generated. The last subscale, click transform and click at the compute variable and add the target variable, name it to non-regulation. In the numeric expression, construct an equation of Q2 plus Q10 plus Q13. Click OK, the new data of non-regulation will be generated. For the total score, use the same step as the previous one. Click transform and click at the compute variable, then add the target variable, name it to total score. In the numeric expression, construct an equation of all questions Q1 until Q18. Click OK. The new data of total score will be generated. Now, select the data to the end. You will see all the compute variables. First, click Transform and click at the compute variable.
Now, click Analyze, click Descriptive Statistic and click Frequencies. Transfer age, gender, type of spot and state the spot. Tick to create APA style tables to the variable box and click OK. The data of descriptive statistic will be generated at the output. Click Analyze, click Descriptive Statistic and click Descriptive. Transfer age and CGPA and click OK. The descriptive statistic for age and CGPA will be generated at the output. Last but not least, for the descriptive statistic of every subscale from the questionnaire, click Analyze, click Descriptive Statistic and click Descriptive. Transfer intrinsic regulation, integrated regulation, identified regulation, interjected regulation, external regulation and non-regulation to the variable box. Click OK and the data of every subscale from the data will be generated. Now, click Analyze, click Descriptive Statistic and click Frequencies. Transfer age, gender, type of spot and state the spot. Tick to create APA style.
The research objective of this study is to examine the relationship between sport motivation and academic performance among students who are active in sports. Therefore, the null hypothesis states that there is no significant relationship between sport motivation, measured as the total score of sport motivation, and academic performance, measured using CGPA. And then the alternative hypothesis states that there is a significant relationship between sport motivation and academic performance among students who are active in sports. For the significant level for this study was set at alpha equals to 0.05. That means that if the p-value obtained from the analysis is less than 0.05, the null hypothesis will be rejected. Before conducting the inferential analysis, several assumptions for Pearson correlation were checked using SPSS. The first assumption is that both variables are continuous. Sport motivation and academic performance measured using CGPA are both measured at the skill level. Therefore, this assumption is met. For the second assumption is related pairs. Each participant provided one score for sport motivation and one corresponding score for CGPA. Hence, this assumption is met. For the third assumption is independence of observation. Each participant was measured only once and the responses were independent of one another. Therefore, this assumption also met. For the normality of sport motivation and CGPA was assessed using histogram and normal Q to Q plots in SPSS. Visual inspection showed that both variables were approximately normally distributed, and then the normality assumption is met. For the scatter plot was examined to assess the linear relationship between sport motivation and academic performance. The scatter plot showed a roughly linear pattern between the two variables. Therefore, the assumption of linearity is still met. Box plots were used to identify potential outliers. No extreme or significant outliers were detected for either variable. Hence, the assumption of no significant outliers is met. So, since all assumptions were satisfied, Pearson correlation was appropriate for this analysis. So, for the normality test and linearity, you have to click Analyze and then Descriptive Statistic. After that, click Explore and then click CGPA to Dependent List, and then click Total Score, also to Independent List. After that, click Plots, Histogram, Normality Plots with Test, and then click Continue and then OK. After that, you will get the test of normality and linearity. So for the normality test and linearity, you have to click Analyze and then Descriptive Statistic. After that, click Explore and then click CGPA to Dependent List, and then click Total Score, also to Independent List. After that, click Plots, Histogram, Normality Plots with Test, and then click Continue and then OK. After that, you will get the test of normality and linearity. So for the normality test and linearity, you have to click Analyze and then Descriptive Statistic. After that, click Explore and then click CGPA to Dependent List, and then click Total Score, also to Independent List. After that, click Plots, Histogram, Normality Plots with Test, and then click Continue. Next, for the scatter plot, you have to click the graph and then legacy dialogues, and then scatter/dot, and then define. After that, click CGPA to y-axis. After that, click total score to x-axis, and then click OK. Next, for the scatter plot, you have to click the graph and then for the test statistic, you have to click analyze and then correlate, bivariate, and then click CGPA to variables, and then also total score, then click OK. So then you will get the test statistic graph. And then for the test statistic, you have to click analyze and then correlate, bivariate. A Pearson correlation was conducted using SPSS to examine the relationship between sport motivation and academic performance. The results show a correlation coefficient of R equals to 0.049 with a p-value of 0.830 based on sample size of 22. The p-value obtained is 0.830, which is greater than significant level of 0.05. Therefore, the null hypothesis is not rejected. This indicates that there is no statistically significant relationship between sport motivation and academic performance among students who are active in sports. So, in conclusion, this study examined the relationship between sport motivation and academic performance using Pearson correlation. Based on the SPSS analysis, the research objective was not supported as no significant relationship was found between sport motivation and CGPA among students who are active in sports.